Hello. Oh, there we go. Welcome to a developer's guide to GraphQL implementation. Before we get started, a quick forward-looking statement. Go. We'll be talking about some new releases coming up soon. Please don't make any sorts of business decisions based off of this information that we present today. So, quick intros. My name is Rohan Bediuncle. I'm a product marketing manager here at MuleSoft. Joining me today, I have Gaurav and Antonio. We're very excited to be here with you today at TDX in person, which is awesome. So yeah, let's dive into the presentation. So, quick intro to MuleSoft. For anyone that's new or doesn't know a lot about what we do here, one of the big kind of goals we have is to help our customers work smarter, not harder. We do so by breaking down their assets into reusable building blocks. And these reusable building blocks make up the foundation for what we like to call composability. So what's composability? Composability is taking these sorts of reusable building blocks and actually creating new experiences, new products, and new services faster and more efficiently, all without the use of custom code or point-to-point integrations. I think one of the best examples of this is seen in our API-led architecture. This architecture helps organizations organize their APIs into 3 distinct layers and allows them to accelerate delivery and simplify management and upkeep their APIs. But with an ever-growing number of back-end APIs to consume from, so like databases, APIs, services, and an ever-growing number of front-end applications that need to grab data from those back-end services. We're kind of asking the question, where do we go from here? And so this is where technologies like GraphQL truly shine. They're the evolution of consumption from a composable architecture. And I'll repeat that because it's important. They're the evolution of consumption from a composable architecture. So using technologies like GraphQL, you as developers can actually unify all of your backend APIs into a single endpoint, all governed by a unified schema. What this allows you to do is request data from any field within any of the APIs that are associated with this endpoint. So this turns tasks that might have taken 5, 10, or maybe 10, 20 different API requests and turns them into just one. So today, we're going to be talking about 3 core concepts of GraphQL implementation. We're going to start out by talking about how developers can automate the unification of GraphQL or APIs into a GraphQL endpoint. And then we're going to be moving on to, once you create that endpoint, how front-end developers can actually leverage the endpoint to easily retrieve data. And then we'll be taking a peek behind the curtain and taking a look at some of the out-of-the-box performance features that you get with some of these GraphQL solutions that allow this to work. So, in order to do this, we're going to be following the journey of Frank. Frank is a mobile applications developer at a company called Mythical. Now, as part of Mythical's digital initiatives, they are tasking Frank with exposing order information and shipment information to customers via a mobile app. So, traditionally, in order for Frank to do this, he would have to leverage Mythical's extensive API ecosystem. This is thousands of APIs with little to no organization, almost like a black box of information, or in this case, a blue box. So, Frank would have to tackle this problem in a series of steps. First, you'd have to go through and actually identify which APIs or data sources he actually needs for his project. Next, he would need to actually authenticate to them, right? This is going to have him working with some sort of third party, maybe a back-end team, maybe even that dreaded ticket to IT for access to it, right? And then finally, Frank's going to need to implement some sort of new code, write some new logic to actually isolate the fields from those APIs, and then pull that data into his mobile application. All in all, this is going to take, go back one, Frank's quite some time to do. He's going to end up spending more time actually trying to get access to that data than building out his UI, right? And that's so fun for Frank. So, luckily, Mythical has started using Anypoint DataGraph. Anypoint DataGraph is MuleSoft's GraphQL solution. So using Anypoint DataGraph, Frank can make one single request to that single endpoint and get access to all the underlying information that he needs for his project. He actually doesn't even need to know what APIs these fields that he needs for his project are part of. All he needs to know is that he needs these fields. He makes that request to the unified schema, and boom, just like magic, he has his information ready to go in seconds. But how does something like this get set up in the first place? So, since Mythical has only recently started using Anypoint DataGraph, the APIs that Frank actually needs have yet to be added to his unified schema. So, we're going to be going through today in a demo how backend teams, 3 backend teams, can add their respective APIs into a unified schema. Now, you might be asking, this seems like it'll take some time. But I'm very excited to announce here today that in the next month, we'll be releasing a new feature for Anypoint DataGraph that will make this process a piece of cake for developers, announcing CLI for Anypoint DataGraph. So with CLI, you will be able to instantly implement GraphQL APIs at scale, and you'll be able to automate this process through your CI/CD pipelines. On top of that, you'll also be able to help deliver your projects faster by decoupling front-end and back-end teams. And as one added bonus, even if you're not a MuleSoft developer, you can still take advantage of this with your existing tools and your existing tech stack, which is really, really cool. So to help kind of demo this and set this up, I'm going to pass it off to Gaurav to take over.
All right, so let's talk about the demo. So the key task is very evident. There are 3 APIs, and there are 3 backend teams, and Frank needs APIs, and this information from fields within those APIs. Very complex, challenging, right? But we are going to simplify it. So what we're going to show you how each of these backend teams can individually add their APIs into the unified schema by integrating that with their CI/CD platform of choice. And there's literally no fuss. You're not going to see any Salesforce or MuleSoft specific technology that they're using, literally leveraging what they're existingly using. So let's go into the demo and see how this really works. So at a high level, the demo is essentially 3 points. The first one is you have to add a dependency to your API project, and that would be something around the extensions that I'm going to talk about a little in detail. The second one is updating your CI/CD pipelines with the CLI commands that we are releasing. And the third step is triggering that CI/CD pipeline. That's pretty much it. It's simple, and let's see how it really works. So on the screen here, you are seeing the API project, and you can see in the dependencies block some pieces around project and data graph and extensions. That's essentially a copy-paste that the developer has to do. The backend team will literally copy-paste it. And then the next section is adding the CLI command. So this is a file. This is a bash file, a shell script, which has 3 parts to it. The first one is you create a bundle. You are creating a bundle of the dependency that we just created, as well as the API specification. Then you publish this bundle, the zip file, into Exchange as your second step. And the third step is adding this to the unified schema data graph, which should give you a GraphQL API. Let's see how this really works. So in the last step, you have your API specification, and you add certain extensions. And this is what I was talking about. This is a small little piece that has to be done all declaratively, no code again. So what we are doing here, we are talking about the sale API. The backend team will say, how do I access the sale API? What's the primary key for this? And the ID is the primary key to uniquely identify a sale object. Then how do I link the sale object with other APIs? And this is interesting. By doing a primary key and a foreign key kind of references, we are saying that the sale object maps to the shipment object in the shipment API on this key mapping, the shipment ID to the ID, and the order with the order ID. And that's pretty much it. The last step is they just say how to access the sale API, which becomes a query method, and you have to put the entity provider. The entity here becomes the sale if you are aware about how GraphQL APIs work, like you have entities and types. So this is what's happening here. These 3 changes in the API specification, and that's all. Let's go into actual implementation. This is all done. Let's commit these changes. These 3 files, let's add them in. All right, so we have added these 3 files. Let's push them to our favorite CI/CD pipeline, Heroku, but it could be anything that you're using. GitHub Actions, it could be anything. And this starts the build process, and this should start. This is a live one, so it's taking some time. That also proves this is live and not scripted. All right, so we go to the Heroku app. Let's refresh it. The build process has started. Let's see what's happening there. Regular things, it's building an image, something that you are very aware if you're in the developer community. This is how it works. Should take a couple of seconds. It's doing some integration testing. And now, let's see. It's still in progress. Heroku is pretty efficient. If you haven't used it, you should try it. All right, so this is almost towards completion. And now it's deploying. This is the step where we added our DataGraph CLI commands. And let's see those 3 steps here. So the first one was creating the asset bundle. If you scroll up a little, Antonio. The first step is an asset bundle. This is a zip file which was created. The second one was publishing this into Exchange. And the third step is adding it into the data graph. And you can see some part there. And this says it's done. So let's see if it is really done. So let's go to the data graph UI. And then we can see the sales API is here. So that's a relief. And let's see if we have the right methods. So you can see sales by ID. What happened, we have a resource, an HTTP resource, which is of type GET. And we translated that into a query method really efficiently. And let's see if the linking has been done. So the sale object did not have the shipment and order information. But now in GraphQL, it has. You can see that the links have been complete. And you can see a shipment object and an order object. Let's explore a shipment object and see if it has all the fields. Oops. You have to go to the schema and then look into the shipment object. And you can see it has all the information that the shipment API was bringing in. So now we have integrated all these 3 APIs, and we are providing a single GraphQL API endpoint to the Franks of the world to use. Let's see how Frank will use it. This summarizes and ends the demo 1. But let's quickly go into the next part, which is backend teams have done their job. They have added their APIs to the unified schema data graph. But Frank still has to consume them. Now, is it a challenge? Is it hard? Let's see how hard it is. So Frank, again, will do 3 things. The first one is he has a query to retrieve the fields, exactly what's required to build the UI. The second thing I'm going to show you is mutations, something that Frank doesn't need right now. But in future, if he has a need where he has to update or create new objects, then he can use that. And the third part is CDN integration. There's a big debate about that GraphQL doesn't support CDN integration or caching. So I'm going to show you how DataGraph supports that. So in the demo, we're going to see here on the screen that we have the GraphQL endpoint. You can see it ends with a GraphQL. This is coming from Cloud Hub. And there's a client ID secret. And we're going to move on to Postman. This is, I believe, another favorite product of yours that you use. And we already have copy-pasted the GraphQL endpoint into the URL request and the client ID secret in the headers. And you can see the first query. This is the fields that Frank really needs. And he already wrote it down. Antonio did it, so he's my Frank right now. And let's execute it. Let's see if he gets everything. Voila. So all the fields, you can see it has a shipment information, the tracking, the order information, and the sales information. All has been done completely declaratively without writing any code. And this was literally minutes. And I was talking about it while we were doing it together. But if Frank or the backend teams have to do it themselves, it would literally take seconds. And any future use case where there's any API change made, as a part of the CI/CD platform and that pipeline, it will automatically be integrated to the data graph. So there is no change that the backend teams have to be done separately for data graph. And Frank will continuously keep on getting the new updates right into the GraphQL API that he loves and uses the most. So let's talk about a future use case, right? So the business teams comes to Frank and say, hey, we need one more field. What we had before, we need a tax amount as well, a new field which Frank did not have in the query before. It's really easy because that field already exists in the GraphQL API. He just has to add it to the query and pull it. Let's run and see if we get the tax amount. So we can see that all the orders now have the tax amount too. So if Frank gets more requests to update the UI and add new fields, he doesn't really have to talk to the backend teams or do anything specific. He has it all right in the GraphQL API. But let's talk about a more advanced case. Frank right now was only querying information. What about if he has to update or create objects, right? I'm talking about post methods. Like we looked at like the get methods. What about post, patch, delete? There's so many things. So that's where mutation comes in. And DataGraph automatically translates all of these other non-get methods into mutations. So as an example, I'm going to show you how we're going to change the status of an order from closed to open. So let's try closing a particular ID. This order was represented by this ID, and we close it. Now let's open it. We're going to open it again the same way, and it opens. It's leveraging the existing post resources that have already been created, so there has been no new work on the backend teams, and Frank is literally happy getting everything that he needs right from a single GraphQL endpoint. Now, this is not it. The best part is a problem. So because this page that Frank created is so heavily used, there's a big amount of traffic coming to it, and that's impacting the backend servers, the backend APIs, and they didn't understand the scale that it would have. So what Frank can do now, so Frank knows that DataGraph supports CDN caching out of the box. There is literally nothing Frank has to do. So let's see how Frank can set up the CDN integration and improve the performance as well as provide a better customer experience. So Frank goes to AWS, his favorite cloud provider, and adds in the GraphQL API that he was using in the application, provides the HTTPS, and provide the port number and the client ID and secret. And as an output, he will get a CloudFront GraphQL API. So you can see in the URL, now this is CloudFront written. So this is an AWS CloudFront API coming from the CDN. And you can see that the query has been updated a little bit. We have added some extensions, and you can see a hash. This is a standard way how GraphQL APIs are cached. And I'm not going to go into details about what's happening, but at a high level, this hash is of the query. And this query is then cached or hashed in DataGraph and cached in the CDN. So let's see it in action. So we'll run it the first time and see that it took how much? 825 milliseconds, and then you can see some cache control headers already populated for you. This is dynamically done. So again, Frank did not have to do anything to provide cache hints or to do anything. It picks up automatically from the information provided in the REST APIs and populates it. And it's based on the fields. So only the fields which are needed, they take the minimum of that, and that becomes the cache limitation. So that's super powerful. It will change based on each query. And let's run it again and see if the cache really worked. So we will run it again. And the time is 6 milliseconds, 4 milliseconds. And that's the power of caching, right? So this is now taking in from the CDN cache and not really hitting the DataGraph server. And this is a performance improvement in terms of latency, a better customer experience, as well as supporting and reducing the load on the backend services. So I'm going to close my demo. I hope you guys were excited, and I'm going to quickly recap what we did. So first, we showed you how we can decouple the backend APIs and the front-end APIs, and then how the backend teams and the front-end teams don't really need to interface too much and waste a lot of time with deciding what the shape of the request should be, what the new experience API should be. At the same time, multiple backend teams don't need to interface with each other either, and they can just work independently forever. And this is integrated in the CI/CD pipeline, so they will never need to worry about communicating again with Frank any changes that they are doing on their end. And then we saw the power of CDN, which is pretty evident. You guys have seen it with Get and with your REST APIs, but GraphQL takes it to the next level. And because we do dynamic cache control headers, it makes it super easy for Franks to build new interfaces and not worry about latency impact or impact onto the backend services. So I'm going to pass it on to Rohan to wrap up this session.
Cool. All right. Sweet. So now we can take a look at Frank's mobile app, right? And we can see, boom, just like that, he has all the data he needs. Once those backend engineers are actually got the APIs into the unified schema, Frank can access them, and within seconds, he's able to get all the information he needs for his app, and Frank's a happy camper, right? So just to do a quick recap of what we talked about today, we saw how backend engineers can actually automate the unification of their REST APIs into a GraphQL endpoint. Then we saw how front-end developers such as Frank can actually easily access all the data they need through that single endpoint. And then finally, we talked about CDN caching and some of the out-of-the-box performance you get with products like Anypoint DataGraph. So as a final kind of wrap-up, we wanted to draw your attention. If you still are interested in learning more about GraphQL, there is a session happening tomorrow at the Redwood Theater from 11 to 11:20. They'll be introducing the Salesforce GraphQL API, which is really exciting. And just to wrap up, we want to thank you all for joining us here today. We hope you enjoyed the session, and we hope you enjoy the rest of TDX. Thank you.